In this video, we're going to discuss how to implement some of the things that we've been talking about in inferential statistics using Excel. Now, one other thing I'm going to do is show you a little hack that I do to get data easily from Canvas into Excel so I don't have to manually type it. Now, it's very hacky. I actually go through Microsoft Word and then do some stuff and then bring it into Excel. So you don't have to pay attention to this first part if you don't want to, but if you're interested, feel free to check it out. I'm going to go into a Canvas homework assignment. I'll copy this data set. Looks like this is ratings of satisfaction with facilities. So what I'm going to do is I'm going to copy this and then I'm going to open up Word and I'm going to paste the data into Word. Now, the thing is, if I try to paste this with the commas into Excel, Excel doesn't recognize that and put it into individual cells. What I can do, though, is in Word, what Excel does recognize is tabs. So I'm going to try to replace each of the commas with a tab character, just the regular tab as if I typed it on my screen. Now, if there's a bunch of commas, then I don't want to do this by hand. I want the computer to do it. So what I'm going to do is do find and replace. I do Control F to open up the find, and I'm seeing stuff here I don't really care about. I'll go to search for more things, and then I'll see the replace option. Now I'm going to find commas, and I'm going to replace them with an up arrow that's right above the number 6 on my keyboard and the letter T. And this indicates a tab. Now, if I go on and hit replace all, I see that all of my commas are now replaced with a bunch of tab characters. What I'm going to do now is go on, highlight this, and copy it. And now I'll open Excel and paste, and I'll just use Control V. I'll note that because I've done the tabs, all of these are nicely separated. Real quick, this is sideways, and I prefer my data to be vertical. So I'm going to copy this and then right-click right below and paste the transpose. And then I'll go on and select this entire row with the original data and clear the contents. Here, I'll write a little label for my data just so that I can keep it straight. And this was Likert responses. If I were actually analyzing this data, I might have a long label like this, and then maybe something short like fac_sat to remind me that this is facility satisfaction and not take up as much room. Okay, well, we've kind of discussed a lot to do here, but also we've discussed a lot of the components, such as calculating means and standard deviations in Excel already as well. So I guess what I'll do is just come up with a hypothetical scenario and practice working through it here so that we can get some practice. My goal will be to create a 95% confidence interval. And again, 95% is the standard percentage that we use, 5% error, 95% confidence. I'll also want to, so that'll be my confidence interval practice. And then I'll test the null hypothesis that mu equals 6 with alpha equals 0.05. Actually, let's do something weirder than 0.05. Let's do 0.10. And I'll note that I can run this test in both ways, but let's just try it with 0.10 so that we can get the practice at doing two different alphas. That's the big skill that we're going to be practicing here. It's the new calculation in Excel. Is that new alpha calculating the alpha. All right, so for me, what I need to do this is pretty simple. Recall that I need the point estimate, I need the critical value, and I need the standard error. Now, to calculate the standard error, I'm going to need a couple of other pieces as well. I'm going to need the standard deviation from the population, and I'm going to need the sample size. So I'll just go on and list all these out as things that I need to get information on. All right. So for n, the sample size, I can just count up how many there are, but there's also a function in Excel that can do this called, creatively enough, count. So I'll use the count function, highlight my selection, and hit enter, and I count that there are 15 numbers in my data set. That's my sample. For standard deviation, if you remember, we use ST, and we did the standard deviation of the sample. I'll highlight these values, and again, close my parentheses to get my standard deviation estimate. For the standard error, if you recall, we took the standard deviation value and divided by the square root of the sample size. So that is my standard error calculation. For the point estimate, we took the mean of the data, and I'm remembering this time what I forgot in the last video, that in Excel, the command for mean is average. So I'll do average, highlight everything, close parentheses, and hit enter. That's my average. The last thing that I need here is the critical value. And again, this is the big thing that is the additional component within Excel. So this is our big additional thing that we're talking about how to do. To find the critical value in Excel, I use the norm.s.inv command, and then I enter the probability that I'm interested in. Now, actually, I've realized I've forgotten one thing here, so I'm going to pause this, and I'm going to go up real quick. I'll hit escape to get out of that, go up. I forgot to type in my alpha. My alpha for this case is 0.10 for my hypothesis test. So I should list all of this as hypothesis test values. All right. So my critical value, I'll go back again, norm.s.inv, and it asks for my probability. Now remember, in my curve, I have the central space that I want, and I'm looking for the two cutoffs for my critical values. One is the negative one on the left, one is the positive one on the right. So if I kind of mentally draw this out, I have alpha of 0.1. So I want 5% of the error on the left, 5% on the right, and 90% of the distribution in the middle between the two. So for the left tick mark, I'll want 5% or 0.05 less than it. And for the right tick mark, I'll do this again, norm.s.inv. I'll want the 5% plus the middle 90% or 95%. That's 1 minus alpha over 2 on the right-hand side. This one I wrote 0.05. I should, if I'm using the equations in Excel, do alpha over 2. That is the area in alpha divided by 2 on the left. All right, and now I have my plus and minus critical values. And this is handy because if I change alpha, so for instance, if I'm doing my 95% confidence interval, I can kind of do the same thing here. I'll just change alpha. I'll copy all of this over, actually, now that I think about it, and I'll paste it here. Looks like I need to redo these. Oh, because the cells that they're referencing have changed. So let's refix this. My count. That's the wrong block. This is the data block that I want. I'll note there's some stuff I can do in Excel. Actually, maybe I'll just show it real quick. You just copy this. And if I right click, I can paste the values formulas. So I could just paste the values straight if I wanted to. What I wanted to show you is, I guess I'll show it here. If I put $ in front of the letter and the number of each element in the range, then when I do this copy and paste, it actually stays the same. The $ lock it in so that when I move it from one place to the other, it doesn't change. So that can be really handy if you're interested in something like that. The standard error, which calculates from the standard deviation and the normal, I do want to change. That should be H10 and H11. Critical value references H6, which I do want to change. And point estimate, E2 through E16. Oh, nope, that's not what I want it to do. So this one, I want that to lock into my original data. So I have to think about when I move these equations if this is what I want or not. In this case, this all looks correct. It all looks the same. I do want to make sure I have the formulas because when I change my alpha to 0.05, I want the proper things to update these critical values to be updated to the new cutoffs. And you can see that because I defined these from the alpha cell here, that does update appropriately. So this will be for my confidence interval, which uses that different alpha level. Okay, so for my hypothesis test, when I'm working through this hypothesis test component, let's think through what I wanted. So I had my null hypothesis, and for my null hypothesis, this was mu is equal to the default. So in this case, I'm going to test a default of mu equal to 6, and the alternative hypothesis was that mu is not equal to 6. And I'll just write NE to stand for not equal to 6. Actually, I'll use a exclamation point equal. Sometimes we do that in programming. All right. So to construct my confidence interval, I needed my null hypothesis value. So actually, I'll go on and write in null mu, so that I can call that later. The test statistic was, I took the equation for the test statistic, and I can go look this up again, but it was the point estimate. So I'll type equal and I'll do parentheses. So it was the point estimate minus the null mu value, and then divided by the standard error. And that was my test statistic. Now, I could have done this standard deviation over the square root of n. In the denominator, I made a standard error box in mine. You can do it however you'd like. But in this particular case, I get my test statistic of negative 3.371. Now, comparing this to my critical value of negative 1.64 to positive 1.64, again, I've got a curve mentally. The cutoffs are negative 1.64, positive 1.64, and this one is way, 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 way out on the negative side. So this would indicate that I reject the null hypothesis. Significant difference. My mean Likert response is significantly lower than 6. I don't know why we wanted to look at 6, but this response is significantly lower than 6. And I'll just go on and move these cells a little bit over so they're not in the way of my my confidence interval. Okay, so this was my hypothesis test that I did. I calculated out all of my components, calculated out my test statistic, and then made my decision based on that test statistic. If the test statistic is in between these critical values, then I would fail to reject, and there would not be evidence that it's lower. That is, I would just stick with the default that it's 6. That would be my default belief. I wouldn't have any evidence to counter that default belief. All right, so for the confidence interval, recall that the formula is pretty similar, but now I'm going to need the top end of the confidence interval and the bottom end of the confidence interval. So I'll write top and bottom, or maybe I'll just do CI, and then I'll do the top on the right and bottom on the left, because that's how we did it in class. Standard presentation. So let me see if I can remember what the formula was. I took my point estimate, the mean, and then I subtracted the critical value. Of course, that's the same thing as adding the negative critical value is subtracting. So I'll add the negative here, but if I just use the positive one, I would subtract it, times the standard error. And that's it. That's the bottom interval. That's it. The top confidence interval is point estimate plus the positive one times the standard error. And again, y'all, I'm not making this up. This is the equations that we worked through in the lecture slides. I'm just going and pulling those. I'm creating a cell where I calculated it out. I used the names that we did to calculate out point estimate, critical value, standard error, so that I can make the equations when I eventually have to type them in to get my answers as easy as possible. And if I do that and I clearly make those associations in my Excel spreadsheet, it makes typing this stuff in really, really easy. So my what percent confidence interval is this? 95% confidence interval, alpha is 0.05. My 95% confidence interval is 3.36 to 5.3. I'm 90% confident that the mean facility satisfaction on this Likert scale is between 3.36 and 5.3. So it's a 4 or 5. I'm 90% confident that the population average is, or 95% confident the population average is in there. All right, what if I wanted to be 90% confident? Well, in the way that I've set this up, all of this is calculated based on the components here in relation to each other. So I just type in 0.1, and this turns into a 90% confidence interval, or 0.01, and now it's a 99% confidence interval. So it's pretty fun to be able to see how the confidence intervals change. Now, if I wanted to be really, really confident, remember what I said about a 100% confidence interval? Let's try a 0.00001 error. That's I want to be 99.999999% confident what my confidence interval would be. Well, even with that level of confidence, I still have a reasonable, usable range to be extremely confident. But if you remember the scale of the responses here, it's from 1 to 7. So this is pretty much saying it's between 2 and almost 7. If I went down a couple more zeros, I wonder if we can break it. Yeah, this is pretty much saying it's between 1 and 7, which isn't particularly useful. So again, typically our usability level that we do is 0.05, and that keeps it reasonably useful. All right, well, I guess one more thing that we could look at is the calculation of the p-value. So let's go on and play around a little bit with the p-value. So for the p-value, recall that we have to calculate the area more extreme than the test statistic. This is a little bit tricky because if the test statistic is negative, we can use the default function. But if the test statistic is positive, we have to do 1 minus the default function. So let me try it out here. The default function norm.s.dist is what we're going to be using here. And then I'm going to give it the test statistic. And then it's going to ask if I want to do cumulative equals true, and I do. I want to do cumulative equals true. And I hit enter, and that is the p-value for this particular test. And excuse me, if you noticed, I forgot one thing. That is just the extreme side on one side. So this is the left-hand side So in Excel, the function's always going to go to the left. This is the left-hand side, but I need to multiply by 2 when I do this by hand to account for the extreme on both the left and the right-hand side. So in this case, my p-value is very, very small, 0.00079. So as the p-value is less than alpha, alpha is 0.1, p-value is smaller than alpha, I reject the null hypothesis, and there's a statistically significant difference. Let's quickly talk through the p-value when the test statistic is positive, just because we're making good time here. So the p-value when test statistic is positive. Let's have a hypothetical test statistic that is, let's say, positive 3.371. So that should be the same p-value as what we had before. It's just looking at the positive side of the extreme instead of the negative. Now, if I type in the same equation, and I'll go on and copy and paste this over, and again, the reference is going to be different, but I'll just change this reference to be related to my, our new p-value here. You're going to get something that is very, very, very different. Ultimately, that's because this p-value here, and I'll take out the times 2 so we can see it, this p-value is the area to the left. So if you can mentally imagine our curve here, this is the area to the left of that curve, or the left of that extremely far right point, all the area to the left. To get the area to the right, we do 1 minus this, and that gives us the area to the right of that curve. And this matches the area to the left of this one over here. So again, this is the more extreme, and because this is a point far to the right, we need to calculate the area to the right, which is 1 minus the area to the left. To multiply it by 2, I wrap this area to the right in parentheses and multiply the area to the right by 2, and that gives me my matched number. So it's a little bit more complicated in Excel when the test statistic is positive. Again, in statistical software, it takes care of the times 2 and even the direction for you, which is pretty handy. But in Excel, when we're making this stuff ourselves, it can be a little bit more complicated. In any case, this was a video on how we can do some of the inferential statistics stuff using Excel. We discussed a hacky method by which I get homework style data to copy into Excel via doing a find and replace in Word. We discussed how we can implement a hypothesis test and a confidence interval using Excel, the hypothesis test with the critical value approach and the p-value approach, and the confidence interval using references to different cells instead of manually typing things in. And through that, we were able to play around and see what happened when we got a really, really strong confidence interval versus a regular 0.05, 95% confidence interval, and play around a little bit with that.